to Heavy Networking. I'm Ethan Banks along with Drew Conway Murray. And one of the things Drew and I discuss in this podcast is the very latest technology. Whether it's a new protocol, a standard, or way of doing things, we chat with the people adopting the leading edge of networking tech and see how it's going. Last year, 2025, was the year of AI finding its way into network operations. And there are lots of you that are skeptics. You don't want AI writing code for you. You don't trust AI to make decisions. You're not sure you see the use cases, and you're exhausted by AI oversaturating the news and marketing literature, vendor announcements, and life in general. You are over it. Now, that's not all of you. Some of you are AI enthusiasts, leveraging all the new tools unlocked by billion-dollar data centers, trying every new thing you can, training models on your network telemetry, and seeing what sort of new, useful functionality you can bring to life. And I'm somewhere in the middle. I demand predictability in my network tooling. Determinism, that is the key word. I must be able to count on my tools, AI included. I've seen AI-based solutions that get predictable results you can count on for network operations, and they were all hard to build. Our guest today is with our sponsor, Equinix's Igor Tarasenko. Igor is the Senior Director, Product Software Architecture and Engineering at Equinix, and he is an AI believer. And this is not a casual belief. There's a lot at stake. Equinix is using AI and enabling you to use AI in their fabric that you can use to build a global WAN. AI is a key part of the Equinix fabric architecture now, and there are good reasons for that. So Igor, welcome to Heavy Networking. And I think a good way to set the stage for this conversation is to talk about building a WAN in 2026, because it is a different game than it was even 5 years ago.
Yeah, and first of all, Ethan, Drew, thank you so much for inviting us to your podcast. So it's really a great opportunity for us, for Equinix, to share how we are thinking about AI-ATO networking. And again, it's not only me who is a believer at Equinix in AI. Our company is investing very much into enabling our AI-native networking. So, and to start, what does it mean? So when we zoom out and look how enterprises are building their wide area networks, it becomes more and more complex. If you think about all those building blocks that you need to stitch together, your cloud environments, your on-prem environments, your colocation assets at Equinix, your services that you're consuming over internet, all those components become a part of your wide area network. And just think about those building blocks that Equinix, for example, provides to our customers. We have Fabric Cloud Router. We have global wide area network that allows you to stitch your IBX networks together. We have intranet access. We have precision time. We have cloud on-ramps. We have cross connects. We have optical metro connects. And when you are building your network, you need to stitch all those things together. And it's not only Equinix. So your enterprise networking is super complex, and you're consuming multiple building blocks from different providers. And now think about this, how to deal with this resulting complexity of consuming these various building blocks.
It wasn't all that long ago, Igor. I'd be building a WAN. I've done some global WAN work in my past. And if I wanted to do anything that was off network, let's say off my provider's network, whoever it was, AT&T, Verizon, Global, those sorts of networks, it was a thing. It was like, do you guys have a way that I can connect from here over to here? I'm like, oh, well, I don't know. We can find out. Now that's just the standard, as you were describing. You connect to a whole bunch of different networks. The internet is probably in the middle of it all. Equinix might be in the middle of it all depending on where you are. And it is just a different way to stitch together a wide area network here in 2026.
And Ethan, think about what has changed since I was building my enterprise wide area networks 10 years ago. What has changed beyond just more and more building blocks? How dynamic this network has become. So, because when we were building those things with our traditional telco providers years and years ago, it was a project, right? A huge project. So I'm deploying something on this provider, right? Think how it's happening today. I want to consume this LLM from this cloud service provider. I want to deploy this workload on this in this location in Equinix data center. I want to connect something over Verizon or over AT&T, but through Equinix to cloud service provider. I want today this bandwidth. I want tomorrow totally different bandwidth. So it's not only the amount of building blocks that we have recently introduced and what is considered now to be wide area network, but that dynamic nature of the current enterprise networking, that's a big thing that we have introduced in the last 5 years.
It's huge. It used to be a contract, significant lead time, at least weeks, if not months, to get a new circuit provision for the bandwidth between whatever the two endpoints were that you were trying to connect. It was a very big deal. And building lead time in was such a normal part of the project. It was almost like, yeah, I'm not going to have to worry about that install for a while. So, okay, let's get that ordered, and then I'm going to forget about it and go work on other things. Now it's on demand, and I can make changes, and the contract terms are very short. I need to move data from here to here, and then I'm done with that circuit, so I can stand it up and tear it down and do it all on demand. That was unthinkable not all that long ago.
Do you feel like the process is more software driven these days, Igor?
It's 100% software driven, because how you can enable this type of fluidity in your network when you're trying to do this manually. And just go back to what Ethan said about requirements to the time or delivery time. So just this summer, we had a customer at Equinix who told us, I need 100 gig ports for this sport event in this venue in 3 or 4 hours. Can you imagine this? And it's not just sports. I need these ports on Fabric for private connectivity to create 100 gig connection to some destination to translate that sport event. So that's kind of, even when we were thinking what is digital, what is not digital, of course, instantiating Fabric Cloud Router on Equinix Fabric in seconds, this is a virtual thing. This is purely digital thing. Yes, it can pump terabit per second, but it's not physical router. I need to install, I need to power, I need to patch cord. But now we are thinking even about some physical attachments to the network as some digital event, because what else is this? So port is now a digital asset, how Equinix Fabric customers are thinking about ports. I need port to connect privately to some destination somewhere in the world. Just remember, again, it's not just connectivity somewhere in data center or somewhere in our IBX. It's connectivity that we have to provide across 70 metros on all 6 continents. So, and that's kind of dynamic that customer expects from us that cannot be delivered through just manually. Oh, file a ticket. So I will configure this.
So, okay, software, everything is software driven. That means APIs are involved on some level or another. And that's most network engineers, they're leveraging APIs, not a new concept for most of the people that are going to be listening to this, Igor. Now, in our planning calls, we're getting ready for this show. You made me think that you really believe the API is the new CLI. And there's a lot of people listening that even though they're using APIs, like, come on, man, API is the new CLI. That's a little too much. But you, I think, correct me if I'm wrong, but I think that is your perspective. Why do you feel that way?
100%. It's not just our feeling on the Equinix side. That's what we hear from our customers. So, and that's the best thing working at Equinix. You have 10,000, the most sophisticated and the largest companies in the world. And we have clear requests from customers. Can you shut down portal access for my employees to change anything in the network that I'm building on Equinix? Because I want everything to be done programmatically. Because going back to our complexity story, and Ethan, how you started with I want to have network to be predictable. How you will achieve that predictability if you have manual configuration in your network? So what you want to have, you want to script, you want to test this in your pre-prod environment, you want to achieve repeatable results. Whenever you're running this script, you're achieving the same outcome. And after that, you will execute the script in your product environment with 100% insurance that it will work exactly how you are expecting. So
you just made some
way,
network engineers who pride themselves on being able to log into the device and make it do the thing a little sad, but I was one of those. But I made my share of mistakes, I must say. So the modern world of infrastructure as code and Git and being able to test before you deploy and so on is pretty wonderful.
Yeah, we are literally API first. What it means, you cannot even get sometimes this capability in our console, in Equinix console, because first we are releasing that capability in API. And when I'm speaking about API, I'm not oversimplifying, it's just REST API, right? There are a lot of behind this. So it's REST API. We are supporting, for example, Go, Python, Java SDKs. You can plug this into your application that will drive this change in the network. It's not even engineer, my point, writing the script and using these APIs. It's automation system on the customer side that using these APIs. It's Terraform, it's Pulumi. You have not just executing single operation. That's what is API about. You're executing some flow and you're planning that flow in Terraform plan, and you will run and that Terraform plan. And just again, think about this. It's not only Equinix. Equinix is always in the middle. So when we are enabling this, we are enabling that customer can run Terraform plan that will execute something inside of their collocation private environment. After that in Equinix, and after that somewhere in CSP environment. So, and this end-to-end connectivity, you cannot just go and enable this performing manual operations everyone if you want to achieve repeatable results. And we have customers on Equinix Fabric with hundreds and hundreds, almost 1,000 different resources. How you can imagine managing those thousands of different resources manually?
So you talked about infrastructure as code. I tend to associate that phrase more sort of on the website or the developer side with folks who are, building out things in Kubernetes or in virtual environments. What does it mean for a traditional network engineer to start thinking about infrastructure as code in an API first environment?
This is a great question, Drew, because you're absolutely right. Somehow we've been associating for a long time infrastructure as code with compute environment, storage environment, containerized environment. But how those environments and even networking, but within those kind of environments with very defined boundaries, right? This is my networking, but within VPC environment, or this is my networking within my local environment. What we are extending and what is Equinix is preaching about, wide area network environment, and that's where Equinix provides services. It becomes part of this infrastructure as code. So we are becoming, and I mean global networking, is becoming part of application deployment. That's what we are preaching, because application is not anymore confined to some particular environment. Think about especially now distributed AI and AI applications. You have inference in one place. You might have fine-tuning in totally different place. You might have your agent running in this particular place. You have guardrails implemented as a SaaS somewhere else. This is already global networking that you need to create for this application. If you have infrastructure as code, tools and everything that just help you to set up all those various environments, and you don't have infrastructure as code tool that stitch those environments together, you're ending up in this siloed and patchwork automation that still requires a lot of manual troubleshooting, manual deployment, manual design decisions.
when you said Equinix is in the middle and it's one part of a larger flow, that customers are deploying an end-to-end circuit, building a service out, Equinix is just one piece of that. And so if we're dealing with infrastructure as code in a larger flow, Equinix needs to support programmability and infrastructure as code end to end so that the customer can build out that service. You're not, and this is interesting because historically, you think of things in networking a piece at a time. Here's a switch, and I'm going to set up the routing, and that covers this part. Okay, now I got to build a VPN tunnel, and that's a separate thing. And you would think of it all one step at a time to build this service that you'd be delivering to the business. But in your head, or in my head, it would be this, I got to do this, and then I got to do this, and then I got to do this. When in fact, it's now all one thing. And yes, there's still these individual pieces, but it's part of a much larger whole that needs to be delivered. And if you can't do it all programmatically, that's a problem.
Exactly. And again, think about that old way of delivering this, setting up every piece together, go step by step, checking, rolling back, checking again. So this is the missing part that networking in the current environment cannot, and I mean wide area networking, right, cannot behave that way. So you need totally different approach, and that's where Equinix deliver this neutral, very well integrated, huge ecosystem. So again, that's the promise of Equinix. You can connect anything from any source. It is your location in Equinix data center. It is your on-prem networking, and you're connecting over Verizon, over AT&T, over Lumen. This is your virtual device deployed on Equinix as a network edge device. This is your colocation network at Equinix. So you're connecting from, and you're connecting to. You can connect to precision time source on Equinix. You can connect to cloud service provider. This is AWS. This is IBM Cloud. This is dozens and dozens of different service providers. You can connect to internet access because that's part of your still wide area networking. You can connect to internet exchange endpoint. And again, it's not just to any, it's anywhere, right? So you might start connecting your thing from location in the US and end up with connecting to destination in Frankfurt or in Singapore. So, and it's not only about even this, it's just you can connect from anything, you can connect to anywhere, but you're connecting in any way, right? So because you might need just physical connection. So you're do it yourself. So you're just building patch cords, right? And that's still part of your network. You might use Lambda, you might use layer 2 connection, you might use layer 3 connection, and maybe different parts of your network requires different building blocks. And that's what Equinix is saying. Without stitching all these things together in a logical way, in a very, very well integrated way, it becomes real hard work to build and maintain. It's not just to build, it's to maintain this network environment.
Yeah, can you talk a little bit more about that? Because I feel like most of the conversation regarding networking as APIs now has been about provisioning. I can use APIs to set up connections, but what about sort of ongoing monitoring or even running a ping or a trace route? Is that now API driven as well?
This is a great question. Again, originally, if you think about software-defined networking, we've been focusing on how to push configuration in the network, right? That's what software defines, right? And then we'll have SNMP, we have some tools to troubleshoot that stuff, right? Right now, without automating all three stages in network lifecycle, it's simply impossible to claim this is a programmatic networking. So, and when I'm saying three stages or three phases in network lifecycle, I'm thinking about design, I'm talking about deploy, and I'm talking about troubleshoot, operate. So all three things must come together. You cannot deploy if you don't know why you made this design decision, right? So it should be documented. It should be, again, programmatically defined. This is my desired state. You're deploying, and now you need to have programmatic tools to check that what you planned, you deployed, and now you achieved those results, and you're closing that circle, right? So if you're troubleshooting, if you're operating signals telling you need to change design, you're going back in that loop. So automating
it's obvious when you say it that way. It is obvious when you put it that way, Igor, but it isn't the first place people go, right? We've been all about, pushing configuration into the network, and then we test however we test. Testing, Drew and I attend all the Network Automation Forum AutoCon conferences, and there's been a few talks that have come up about testing. This is how you do testing. These are what unit tests look like. These are the kind of things you should be testing, and so on, which kind of highlights the fact that it's not taken for granted that if you're living in the world of infrastructure as code, that you are doing testing. The fact that we got to highlight this. We got to have talks about how to do this, and that you should be doing this, and how to get testing that validates results in a meaningful way so that you can safely move on to whatever the next part of your process is. So to have all that in place is, again, you say it, Igor, and it makes it sound like it's obvious to all of us, and maybe it is, but it's also kind of like when you write your first script, the thing you don't do is sanity check your input. You're like, I'll get to that eventually, and then you never get to it. Some of us never get to the testing part, maybe.
Yeah, and that's why what Drew mentioned about, for example, ping and trace route. It's interesting. Last year, Equinix introduced ping and trace route as a REST API in our programmatic tools. And when we start building that API, we just realized you can find a model how to model BGP configuration, right, in REST. So a lot of examples. You can find how to model port configuration in REST API. But when we looked into these observability use cases, there's no even standard. How ping, how trace route should be exposed as a JSON object, right? That's what REST API is about. So we use some open source tools. We converted those ideas into some model because it's not just ping, it's not just trace route. It's just, you need to remember this command is continuation, exactly, Ethan, as you said, of your flow. You have just created Fabric Cloud Router. You have created connection from this Fabric Cloud Router to Azure VPC and to AWS VPC. And now you need to test and you're testing from this cloud router to this VPC. You hear this kind of abstraction that I'm using. You're not pinging from this IP to that IP. So in your API, when you're building this automation, you're using higher level abstraction. So that's again what has changed. So because you remember we've been talking about this network automation, intent based, how we can hide this is Cisco box, this is Juniper box, and that was kind of intent based networking that I can abstract. So I can just create a EVPN across different vendors, right? This is much more today. So this is higher abstraction that allows you to say, look, create router, attach to VPC, and then test with trace route, with ping. We are providing in our API, for example, active routes, learned routes, discarded routes or rejected routes, and you're expressing what you want to achieve using that level of abstraction. And your automation will eventually figure out what IPs were used, what ASN was used, how BGP was set up, because that's not what you care about. You care about the outcome of this connectivity that you're creating, for example, stitching AWS and Azure over Equinix.
So we've moved into the age of, APIs. people are using Python scripting, maybe even Terraform infrastructure as code. And now here comes AI. And you've been talking about, we're already at, one layer of abstraction with APIs. Now we're bringing AI into the mix, which needs to understand perhaps even more context. So how do we make that leap into this AI environment?
And that's super important thing that you mentioned, Drew, context, right? Because what API and infrastructure as code-driven approach is not providing to you, to us, to enterprises today, the context, right? So I'm exposing to you, my customer, 230 service endpoints on Equinix Fabric. You can do everything using software to set up your networking on Equinix. But what is context? How to stitch them together? It requires human. Human is writing these complex scripts because human understands what needs to be first. I need to create port. I need to create cloud router. I need to create virtual connection from this port to cloud router. I need to set up BGP session on top of this. I might need to tune BFD timers for this session. So this all context that we humans keep in our minds. So, and that's where we believe API is changing this. So because having only API-driven automation is not enough. And this, the opportunity for us to leverage large language models to create, to maintain, and to operate within the context of this kind of human intent, what we want to achieve. And this what we see large language models can figure out. So they can figure out based on the intent what sequence of operations can be performed to achieve this outcome that a human wants them to achieve.
So the LLM is almost like sort of a context and intent interpretation engine that my user has prompted me to do this. I have to go and figure out how to reach that outcome.
It's more, and we can arrive to this, Drew. So because I feel we should end conversation with this statement, because I feel when we speak about AI, we are trying to oversimplify because it seems like so big. So, and we kind of trying to narrow down what is this about. And the point we are making here at Equinix, AI is a hard work. So it's not one-time project. It's not magic that, okay, I will have LLM will figure out my intent, LLM will create sequence of actions, those sequence of actions will be executed, my intent achieved. Yes, this is end goal, but there are so many things that needs to be happen to achieve that goal. And I just don't want to sound like overhyping. So what is possible and where we are right now. So let's be super careful. When we are true believers in AI, we are very, very pragmatic at Equinix. We truly understand how important this reliability, predictability, and let's talk how to achieve that and stay that, Drew, you mentioned.
Okay, we started this part of the conversation with context. When Drew and I have been in a lot of different presentations where folks that have made use of AI and applied it to network operations, the first step, and it was a huge one, was getting their data sorted. Lots and lots of data to feed into various AI models or various machine learning algorithms. Getting the data sorted out and in such a way that it was digestible, that AI could act on it in a meaningful way was a key here. Logs, SNMP information, a variety of other observability data. What are your thoughts there, Igor? Can you comment on that?
That's a great question. That's where context starts from, right? Observability, and that's when Equinix starts story about fabric intelligence or our AI vision with observability. So observability becomes a perception layer for AI automation, AI-driven automation. So if you cannot see what's happening in your networking, you cannot automate. And that's what we mentioned today. So usually I'm going with CLI, I'm doing the ping, I'm checking my memory, I'm checking my error rate on my interfaces. Now, this as a human, what we were able to achieve, now our agents must get access to that data. So, and it's not only about this kind of setting up machine learning pipelines, going through logs. It's again higher level of abstraction. So it's again kind of filtered out all that noise from the system and getting those meaningful signals into agentic layer that agentic layer can use as a trigger for decision making and for actions. So that's how at Equinix.
Go ahead.
Yeah, just as an example, Ethan, at Equinix, we launched last year that we are able to send observability data, to stream observability data into something like 9 different collectors. Splunk, Datadog, ServiceNow, PagerDuty, Grafana, OpenTelemetry-based, Cloud Event-based, webhooks. And we realized, yeah, that was something that customer needs because they are stitching all this data together, they're making decision, and they're coming back with some action, right? Okay, I received this data, I'm coming back, I need to change. Think about this loop that we have created. It's taking time. It's taking time to get the data from the network, to process, to send, to correlate, to get back into this network, to apply the decision that maybe you have not considered all data, because that's your point of view, what needs to be done. So with this kind of observability and shortening closed loop, so when the data can be fed immediately inside of Equinix into agentic layer, and that agentic layer can suggest, I'm not saying just immediately change your configuration, but can produce some suggestion what needs to be changed. So that's what we see already is a hot topic.
You mentioned 9 different places you could be streaming data to, a whole bunch of data sources, telemetry, and so on coming inbound. Correlation is the magic to me there. Where does that happen?
Again, there are 2 layers of correlation. And again, we keep going back, what is Equinix role, right? So number 1, we can correlate across all those different components we have inside of our platform. And we can correlate using all those inputs or integration interfaces. But Equinix is in the middle. So we can correlate what we see passing our platform. So that's where we see this, what I mentioned, this emerging idea of using agents to do that correlation and suggestions and maybe eventually active actions important. But because we are in the middle, that's why we are we are heavily investing into sending this data into customer observability platforms. Because again, we are in the middle. Customer will be correlating. Just as an example, Ethan, just recent example of a huge customer who built a lot of connections over Equinix. And customer is global. So they have presence in APAC region, they have presence in EU, they have presence in AMER. And they're heavily monitoring their wide area network. And they're observing, here's a spike in latency from Hong Kong to Frankfurt or to London. Why this spike in latency has happened? This spike happened because something inside of their local area environment or inside of their collocation deployments, is it spike because something is happening in that destination environment? Or this spike because something happening at Equinix, because we are passing the data from Asia to Europe? How customer will figure this out? So with this streaming telemetry, what we are providing, look, we are giving you all the insights we have inside of Equinix. And if you know, that's a real example. You remember that Red Sea cable cuts in 2025. So due to all those geopolitical events. So what was happening? As soon as that cable was cut, we were automatically rerouting, because Equinix has sometimes 4 different passes to get from one location to another location. We are rerouting to a different path in our network. Of course, different path has different latency. And of course, very often it will be higher. As soon as customer receives from us in real time, look, now this latency between these 2 metros are going up by 10 milliseconds or by 20 milliseconds. Mm-hmm. And you see in your end-to-end latency, you have increased in 20 milliseconds. You know, we contributed to that latency. So this is just an example of those correlations that, again, much more complex than just, I can correlate inside of my domain. So it's how I can contribute to end-to-end observability on the customer side.
So given the importance of data in an automation and an AI environment for observability, for context, are you seeing standards emerge around things like telemetry so that, the way Equinix thinks about AI, you can ingest data versus, people you have to partner with and your customers, they might have different approaches. You mentioned, the difficulty you found in modeling ping and trace route for an API because there wasn't sort of a standard around it. So is that kind of thing going to be an issue we're going to run into? And are you seeing any standards emerge to try to address the data issue?
There is some standardization approach. Metro Ethernet Forum, for example, working hard to go again beyond just ordering, beyond fulfillment, and they're working hard to introduce some standards for example, notification for repair events or for maintenance events. But you know how many RFCs we have in the networking. So you know how many decades we spent to formalize and build those standards. So right. I don't believe so. And that's not kind of what we've been waiting on. So what Equinix is doing internally, we call this unified networking data model inside of Equinix. What it means, whatever resource you are consuming from Equinix inside of our domain, it's modeled as a part of this unified networking. As I mentioned, from patch cord to time source or to peering opportunity at IEX, it's part of this unified model. So that's when you hear from us. And we internally convert everything into these cloud events with defined metadata, with defined resource descriptions. Why it's important? Because when we are going to, again, AI, and when we are speaking about context, we are as humans can easily correlate this thing. I'm sending this measurement to this endpoint from this source. It's maybe about this port and it's maybe about this particular resource. That's not how AI is operating. We need to provide that context. So what it means that inside of our unified data model, every resource, every measurement, even this ping and the trace route, it's attributed. So you can easily correlate, you can easily build relationships. So this is related to this particular resource. This is related to this particular location. This is impacts this particular thing in this hierarchy.
So you're attaching metadata, essentially.
Exactly. Normalizing metadata, standardizing metadata. So that's what this data model, unified data model is about.
Igor, along the way here, we've been talking about agentic AI. That is AI agents that have a specific capability, talking to other agents, other tools perhaps, and doing something. Model context protocol has been an enabler for that. And we talked about MCP. I don't know. I checked, actually. It was a heavy networking podcast. We talked about MCP and also Network Break, Packet Protector, Total Network Operations, Tech Bytes, Day 2 DevOps, the Cloud Gambit, Network Automation Nerds, and probably others. We're talking about MCP. It's huge right now, and it's hard to talk about agentic AI without MCP being part of the conversation. I know you guys at Equinix have bet on MCP as well. Can you give your take on MCP, what it is and why, if you think it's going to be around long term, why you think so?
This is a great question because, as we said, we start our fabric intelligence or AI agentic story with observability as the first enabler, as a perception layer for AI. And the second enabler is MCP. It's actuators. So you can perceive what's happening in the network with observability, and you can change what's happening in the network with tools. And tools, this is MCP. So this is a protocol that allows you to actively change network behavior. So this is the second largest building block in our Equinix agentic framework. And when we speak about MCP, this is again translating what is possible from those APIs that we have today into that language and into those interfaces that agents and large language models can understand and can leverage. So with MCP, we are again investing heavily in that capability. And just for your awareness, in December, we released the first, I keep even losing, is it 50 tools, 60 tools, but the first around 60 MCP tools. And this is our managed MCP tools. It's remote servers. So that customer can use to change network behavior, to get information from the network, to troubleshoot network. And internally, what we are saying, we are going from
just real quick. So as an Equinix customer, that means I can hit your MCP server and then have access to a bunch of tools that I can bring back and have my agents do something with.
Correct. And I will get to this kind of with some practical examples a second later. Cool. But just to complete on this MCP thing, our strategy from API first, we are becoming MCP first. So we are committing that in the first quarter or in the first half of 2026, everything you can do in API will be exposed in our MCP tools. 100% capabilities on Equinix Fabric will be exposed to our customers in MCP tools. That's
how far away is that? It sounds like a pretty active project. Is this
Absolutely.
2026? You'll have that done, or
we'll have it done in either Q1 or Q2 of 2026. It's already available to our customers as a private beta. So you can reach out to me, you can reach out to anyone on our team, and you can. Now I'm switching to this second question from you, Ethan. How to leverage this, right? This is managed MCP tools. What it means, you have Claude code. It's just 3 lines in your Claude configuration or 3 lines in your VS Copilot, VS Code configuration to attach Equinix as a tool to your dev environment. What it means. So now you see in your dev environment, going back to ping and the trace route, Drew, you can ping from Fabric Cloud Router to your VPC in AWS or in GCP on AWS Cloud, saying, Claude, ping, or even better, Claude, check reachability from this cloud router to this VPC. And that's it. So that's what MCP. And next, you can say, upgrade my bandwidth from metro in Los Angeles to a metro in New York. And that thing will ask, you have two connections. Which one you want to upgrade?
So how would you distinguish between achieving tasks via API calls versus achieving tasks via model context protocol and agents?
This is great question, Drew. And there are no direct answers to this question. I want to be provocative here. So because I feel we all, and I myself, making mistake when we are projecting what we are doing today with our CLI, with our APIs. We are projecting what we will be doing tomorrow in the same way, but with AI-driven automation. And that might be not true. Maybe the process, how we are working with our network, will change. It will be not AI-driven automation of those operations and processes that we have today. Maybe those processes and operations will look completely different tomorrow than we have them today. Because look, even today, when we speak about API versus MCP, it's just one-to-one mapping with different experience, right? So we moved from UI experience to API experience, and now this is natural language experience, right? But we are thinking about the same operation. Look, I can ping using CLI, I can ping from UI, I can ping from API. Now I will use natural language model, I will use Claude Code, I will use VS Code to perform the same ping, right? And what is changing for us, it just looks like it's changing experience. It was web experience, it was CLI experience, it was Python script experience, and now it's natural language experience. Is it big leap? No.
But yes and no, because the technology on the back end is different, right? So if I'm using a natural language interface, and I have heard it argued that the NLI, the natural language interface, is going to be the new CLI. That's another thing that some people have said. Okay, but LLMs don't give you the same answer all the time, and we want that as network operators. We want that consistent answer, right? So how do I know that when I use natural language interface and I'm talking to an LLM and I'm looking for a very specific result, I can trust that I'm going to get the result I'm looking for, that I'm going to get that deterministic answer?
And that's a good question, because again, I believe we are moving into this other area of discussion, agentic AI. So because with MCP, with kind of general purpose agents, it's just, Ethan, like you said, so Claude Code can produce one outcome based on my prompt, or maybe even using the same prompt, I can get a totally different outcome, right? This is general purpose agent that I'm using to maybe autocomplete my code or to trace route from one source to one destination, right? So what I believe and what I see is coming is agentic AI, is specialized agents that are built for some specific operations that can produce these predictable results, that have proper guardrails, that have self-checks, that have improvement loops. Again, going back, we should not oversimplify what is AI for networking. AI for networking, what we see today, nice things, right? So like, look, in Claude, I can attach Fabric MCP tools, I can attach AWS MCP tools, and here's magic. So I can create connection over Equinix to AWS using just natural language. I can accept that connection. This is beautiful, but this is more like some improvement in my life, but not dramatic change how I'm operating the network. So what is coming next? But it creates as I said, this foundation for what is coming next. And what is coming next, of course, agents for autonomous network operations. So when you can offload some tasks to this agent, and that agent can perform those tasks on your behalf. And again, it's super interesting. As I said, we are super lucky having super sophisticated customers. So whatever I'm sharing with you is not kind of Igor has or someone at Equinix pipe dreaming, so trying to introduce use case. We have real customers, so who are coming to us and saying, look, I have 2 remote connections over Fabric coming from Latin America to the US. I'm keeping the second connection at this level of this bandwidth. Can you, when you see that my primary connection utilization goes about 60%, can you increase bandwidth on my secondary connection? And when on primary connection it goes down, can you decrease that bandwidth? Or when you see utilization on my secondary connection is going above some particular threshold, can you automatically bump the bandwidth on that connection? And this is my pattern, so because it happens once in a week when some application guys are doing something over these connections.
But when you say autonomous, an engineer's butt puckers, man. How far are we from truly being comfortable with autonomy, or is it you just scope it and you keep the task narrowly defined enough that the risk is small? Is that how we deal with it right now?
Great question. So, and again, this is kind of going back to over-promising and under-delivering, right? So we are just at the beginning of this journey. Let's be super clear. But why we are preaching and why we are speaking about this? You remember, engineering is not building just features, right? For the next 3 months or 6 months or 9 months. The task of engineering team to build foundation for the next 5-10 years. If you are missing building that foundation, starting building that framework, foundation right now, you will not catch up in 5 years in just 1 month what you missed in 5 years. So we are at the, in our opinion at Equinix, we are at the beginning of this journey, but we are focusing on this big thing. So we dream big, but we are starting this journey with some small steps. So, and what I want to say that first autonomous agents on Equinix, you will be able to run this year. We will provide different levels of autonomy. So you might just ask us, look, when you see this change in behavior on this connection, just notify me. If you want to us to upgrade that connection, scale up, scale down, downgrade, you can go as far as that. So, but framework that we are creating and we are building right now, that will be framework that eventually should lead us to this AI native networking of fully autonomous networking that we've been dreaming for years, right?
So Igor, let me push a little bit and say, Ethan, you said you talk about autonomy and a network engineer's butt puckers, but we've allowed load balancers to make decisions about sharing traffic across systems for multiple decades. We let SD-WAN make decisions about which traffic should go over which connection for at least a decade now. And we did it without AI. So what... I guess I'm trying to get at.
So
yeah, go ahead.
Let me comment back at you real quick on why I think differently about that, because those things like a load balancer spraying traffic across pool members, that is a very tightly scoped function with a few rules and guardrails. There's no intelligence there. There's no, I'm taking in a bunch of different data sources and making decisions. I might have a health check involved. I might have some layer 7 inspection involved to help me make a decision, but it's all very bounded by a specific set of rules. And so it feels very controlled with AI and handing autonomy to an agent, I feel much less in control. And because of my exposure to LLMs and knowing that it is not a deterministic system, I'm worried that the decision that's going to be made will be unexpected. So I just wanted to set that context from my perspective, Igor, and see what you have
100%.
there.
That's again how we started this conversation. This is opportunity to get back. What has changed, right? In 5 years, we've been thinking about this modularity, dynamic. What has changed in automation? What has changed in this autonomous? How we are thinking even about autonomy, right? Drew, what you said is true, right? But again, we started internet, I don't remember, 50 years ago. How many these kind of use cases that no intelligence, but there's still some logic, how I can dynamically reconfigure my network. How many use cases I really have? So and how many years I spent to embed those use cases into ISIS, BGP, segment routing, load balancing, right? So what is changing? And this is all kind of betting, right? So when we speak about AI, it's betting, right? So this thing didn't exist 2 years ago, right? So, but what we are betting on, can we start introducing these intelligent or dynamic networking use cases every day, every week, every month? So whenever we see this use case, like, look, now I want to change behavior of this resource based on a larger context than just is destination reachable, is performance at this level or that level. So, and that's what I believe AI opens for us, this new opportunity to think about automation in the network in completely different way. So, and what it means, it's elevating again what we are taking into input for this automation. It's not just this IP address is reachable, this interface counter is at this threshold or that threshold. It might be intent of my high-level application. That high-level application, like one agent won't speak to another agent, and those two agents want to speak privately. That's how we, again, envision our fabric in future. And they will call fabric agent, asking this fabric agent to instantiate private connectivity between these two agents. And how it will be translated down into API gateway configuration, net configuration, attachment to some workflow. Those are details. So it's just networking will be happening at totally different level. That's again our vision at Equinix in future.
Igor, this has been a good conversation. I appreciate the pragmatism. That is, guys, we don't have autonomy today. We see the way to get there. We're working on it. We're building the tooling. We're testing things and so on. We have customers that are actually doing stuff. But yeah, it's not all going to be here today. So I appreciate that. Igor, if people have questions for you, they want to follow up with you about this discussion, what's the best place that they can reach you?
Yeah, please reach out to me on LinkedIn. You can find Igor Tarasenko, so shoot me a message.
And if you're an English speaker and you didn't pronounce it that way in your head, Igor Tarasenko is the way I look at it as an American and pronounce it more in my head. And that link will be in our show notes.
Yeah, my point here, so there's New Zealand English, Canadian English, and now you learn the Ukrainian English. So this should be valid English version also.
There we go. So again, thank you, Igor, for being on Heavy Networking today. And if you want to keep up with what Equinix is doing, they got a blog.equinix.com. Of course, they are on LinkedIn as well. Just search for the company Equinix and then equinix.com for anything else that you want to dig into about Equinix, their fabric, what they're doing with AI, what they're doing with automation, APIs, and so on. And thank you very much for listening to Heavy Networking today. And thanks to Equinix for sponsoring us. Our sponsors are how we bring you the podcasts, videos, and newsletters that keep you on top of the networking industry each and every week. And if you ping Equinix about their fabric to interconnect your data centers, clouds, and so on, let them know that you heard about them on Packet Pushers. We would really appreciate that. Send your feedback about this show or anything else to packetpushers.net/follow-up. Automated robots lovingly deliver your message to our private Slack channel where we can discuss your input. Like, share, and subscribe, and keep your eye on our YouTube channel where all our podcasts along with original videos are being published these days. That's right. You can see our handsome, heavy networking faces on YouTube if you would like to do that. Follow us on LinkedIn and join our community Slack group to engage with thousands of network engineers from around the world. And until then, just remember, too much networking would never be enough.